Good evening, everyone. Am I audible to all?
Yes, sir.
Hello.
Yes, sir, you are audible.
Pransu, we will cover the practice part. Okay. I guess theory is already covered in yesterday's class. Is there
Okay,
anything
sir.
that is remaining, right? Is there anything that I need to cover from week 6, like in the theory part? I guess Samiksha has covered that theory portion, I guess, right? Each and everything.
Yes, sir, ma'am has covered all the things.
Yeah. So in this class, basically, I will take your practice assignment down, and whatever doubt you will have in general, I will take down. Okay.
Can I ask you a doubt from the book that is available in the supplementary?
Yes, yes. Fine.
I'll try to post it on the chat. The question.
Okay.
Let's just, yeah.
Okay. Okay. Fine. What was the class strength of last class? Any idea?
Yes, around 30 to 35.
Okay. Whatever doubts you have, just based on the chat box, we will discuss together. Okay. In the questions itself. Yeah, it's a doubt session. Okay. It's an open session. You can ask anything. Okay. Sir, how to solve for a function to be onto or one to one if it's a cubic or more bigger degree polynomial. Okay. Okay, I'll let you. See, looking one to one, it's easy, I guess. Any polynomial whose degree is greater than 3 or 3, it's easy to check whether it has a one-to-one correspondence or not. Are you guys have seen the formula of logarithmic? That is very, very important in this meeting or like for any log problems. Okay. It's really important. What are the formula are there in slides and all? Let's take a
So,
look. Well,
sir,
yes, yes, yes.
sir, can you summarize everything which is taught in week 6?
Week 6 summary is already done in yesterday's class. If you haven't watched, just go and watch.
Okay, sir. See, I posted this, what do you call it,
Yeah,
screenshot of the problem.
yeah, yeah. Which one? Like the whole problem is
The entire problem with the solution.
okay. Solutions also there. Okay,
Yeah.
So,
what is the issue
mentioned
here?
you please solve the questions.
Yeah, we will solve the question. That's what I am saying.
Okay. So my doubt
We
is
will solve
about
the question together. Yes, yes.
the graph. When I try to put this using Desmo, uh,
Mhm.
the, the curve that is almost parallel to y-axis, it is actually on the negative side. It's on the minus side. But
Are you
here,
able to see the question first of all?
yeah, the
This
question I
one,
put,
no?
yeah,
Yeah.
just a second.
This one, whatever
Yeah, this
is
one.
showing in
Exactly,
the
exactly.
screen.
Yeah. So here the
Yeah,
graph, the curve, the
this one.
the yeah, the curve that is almost parallel to y-axis, that is actually
Mhm.
on the left-hand side uh, of 0, 0.
Okay, you are saying this side,
Yeah.
this
So
in this
this is where
portion.
I'm very
This
confused. Yeah. I just entered these values on Desmo, and
okay.
Desmos is actually showing me the graph that way. So I just want to know why is it.
Which value?
So what I did was I first entered y is equal to e power minus 2 t. I just
Okay,
put that value so that I just want to know how the graph looks like.
okay.
And then I added 100 within that. And then I added minus. And then I placed minus before that 100e. And
Hmm.
so that the graph got reversed.
Hmm.
And I was able to get this picture. But in this picture, when I added plus 50, what it
Hmm.
did is the curve that is almost parallel to y-axis, it is actually on
Mhm.
the left-hand side of
Okay.
y-axis.
Okay. So which graph have you apply in the Desmos? Like you have to go for this 50 minus 100 e raised to the power
Yes,
minus 0.2t.
exactly.
I think graph is right, I guess. Let's see on GeoGebra and Desmos, whatever you are saying.
Yeah, you try it, please.
Can you please revise graph shifting in brief? Graph shifting for log x, Kiran?
Yeah, I understood
Yeah,
that
yeah.
concept. Grass shifting and all that I understood.
So it's a 50
Like when
minus.
it is multiplied by any constant
Mhm.
or
Okay.
negative number, then what happens?
Yeah, if we
To the
add some
function, and if
value to
it is
x,
added,
no, if we add value to x, then it goes up. And if we add
no, no,
So is
then
there
if
any
we add a constant to the x, then it
equation,
will shift to the left side.
yes, 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 that's right.
okay, okay.
But then what happens if constant is multiplied, a negative or
Okay.
positive number? Then also there is some rules for graph shifting.
See, my
Yeah.
only doubt here is I understood the problem. I know, I mean, I can understand how they have solved it and all that. My only doubt is Desmos is not showing the graph in this way. It has shifted it to the left side. So that is where my
It's correct, right? The graph is correct.
graph is
See,
correct.
yeah. I have made this 50 minus 100 type e raised to the
Yeah.
power minus 0.2x. 0.2x.
Okay.
So it's correct. I
For
think
you,
you have done some mistake, I guess. You forgot to write here minus or forgot to write this 100 and all.
I'll just check that. It is 50 minus 100e to the power minus 0.2t. That's what I've done.
Yes. Yes.
For that, the what do you call
It's a GeoGebra.
it is?
It's a GeoGebra. I can show you in Desmos as well. Let me see.
Yeah, please show me that.
Okay, GeoGebra, are you able to see that? Like, I did not share the. No?
I mean, I don't have that when whatever software you're speaking about. I only have Desmos in my system.
Just a minute.
But okay, let me just capture the picture of Desmos that I have, and I'll just show you how it is.
Now, are you able to see the graph? Just a minute. I stopped sharing. I stopped sharing just a minute. Okay.
Oh, okay.
It's my mistake. Okay, are you able to see this graph? Just see.
Just yeah. Here it is so perfect. But let me just share mine also, which is there in the Desmos. I've made almost the same recording, same values. I'll just share it.
Okay.
I'll just send it to you now.
Okay, so like apart from this, what you want to guys like this session? Shall we start solving the question from directly from practice assignment, or you guys are going to paste that question? Like we will not going to take the trivial things, but yes, we will take some. What you want? Just let me know so that it will be easy for me and you as well. What we are going to do. And basically, what kind of question they can ask from this week 7 from this week 7. Okay. Yes.
I just sent that.
Okay, I'm checking. Yeah. In my system also, it's showing incorrect.
Aha.
I think there is.
Now I am just thinking, could it be because I put a parenthesis for 100e, or maybe it is e power something and then multiply by 100? Maybe it's because of that.
Yeah. E power.
Ah.
Yeah, now it's correct. Like I am showing you. Okay, just a minute. I am using Desmos right now.
Oh, okay. Yeah, I think that's a problem. I just changed the value. I mean, I just put 100 out, took 100 out of the parenthesis.
Just see.
Yes. Yeah, got it.
Okay. What you did here? Yeah.
Oh, because of the parenthesis. Okay.
Yes, exactly. You
Oh,
took this minus
minus
0.2 whole raised to the power. Like
yeah, the whole
100, you
thing
are
will be
treating 100. Yeah,
correct. 100 times e to the power of that.
exactly. It's only
Yeah.
for e to the power something, not
Only
100
yes,
to the
yes.
power.
I understood. Okay. Thank you.
Yeah, tell me what you want in this session. Like it's up to you. Like whatever you will tell, I will go through by this way. That way. Could you please explain AQ 6.2 question number 3? Activity question, right? Let me open it. Shall we start one by one from activity question?
Yes, sir.
But it will be kind of spoon feeding, right? I don't want to do that because like if I will solve each and every problem from the activity question, it's I don't think so it will be good for you. Let's see what will happen. How many of you guys have tried the questions? Activity 2, right? How many activities are there? Okay. Okay, fine. You can practice assignment is also graded, right? Some bonus marks is there in practice assignment, I guess.
Yes, sir.
Okay, I am sharing this activity part. Okay, we will go by that way. Okay, are you able to see this screen?
Yes, sir.
Yes.
This activity question 3 not graded kind of thing. Okay, 6.2 question number 3. In this question, Abu, this is not activity 6.3, right? Mine is different. Can you paste that? Oh, activity 6.2. It's 6.3. It's 6.2. Okay, this one, log 2, something like this. Yes. Okay. So what is the question? Consider the function fx is equals to log 2. Okay, this is a nice question. Okay. You have to try this kind of question. Okay, what is the question? Can you please repeat it again? Fx is equals to fx is equals to log base 2 3 times. Log 2, and log 2x. Right, this is the question, right? And from here they are asking like whether this question this f is 1 1 1 2 1 1 and ontoness you have to show, right? Right now the question is how we can solve this kind of question. Solve it. So there are two ways. The first one is by graph. You can go by graph, like how many ways are there for checking 1 to 1 and ontoness? How many methods are there for 1 1 itself? Like there are one nice method known as horizontal line test, right? In the last class, I have explained that, right?
Yeah.
Right?
Yes, yes,
Right.
yeah.
But the thing is, whether I am able to make a graph of this function without the help, without taking the help of any technical gadget and any technology.
Yes, sir.
Manually, am I able to make this graph manually?
Yes, sir.
For a normal person, I'm not saying for everyone. It's difficult, right? There are log 2, log 2, log 2. 3 logs are there. Only one logs. If one log is there, then it is very easy for me. I know what will be the graph. Okay, whoever are saying yes, how will you make this the graph of this? Can you please?
So somewhat similar to technical, like we can
Yeah, it's
find
similar
the
to.
x intercepts, or if possible y intercept if there is,
Yes,
like
but it's
almost
difficult to find y-intercept, right?
yeah,
We
yes,
can
sir.
estimate the graph, but we cannot exactly make the graph because this log thing will be we will be give us some
Yes, sir.
integer kind of thing, like not irrational kind of thing. So it's difficult to find that kind of. We can estimate that
Yes.
how the graph will look like,
Yes, sir.
but what will be the exact graph, we don't know about it. So what will you do? Like the thing is, by checking the graph is not ideal, right?
Yes, sir. It is somewhat ideal, not exactly.
Yeah, it's somewhat not. This is a easy function. If I will give some complicated thing there, like suppose I will introduce some 10x sin x kind of thing, then
Yes, sir. That will be more difficult to estimate
Yeah,
it.
exactly. That's what I am trying to say. So basically what we will do for this kind of cases. And I will explain how will you find the domain of this kind of function as well. Okay. So there
Okay,
are
sir.
two questions that arise from here. Firstly, how we will find the domain of this kind of function. And the second thing is we have to check the one and onto-ness function. Okay. So basically here, as you can see, here something like composition are going inside it, right? If I will consider f of x is equals to log x, then it is looking like f composition, f kind of thing, right?
Yes, sir.
Yes, sir.
Right? As you now you can write it as f of x like this. Right? Right?
Yeah.
Yes, sir.
Okay. So whenever this kind of thing is happen, what will you do? So just look at this f, whether this 1-to-1 or not. You have f and g, two function, then what we will say about this FOG? This FOG will be f of g of x. Okay. Now, what we can say about this one-ness and onto-ness of this kind of function? Okay, just let me know if f is 1, then what will happen? F is 1, then we will say like this, no? Suppose f is 1. Okay,
Then
so
F is
there are two cases. Now, okay, let me explain one by one. Claim or not claim. What my what my need is, our need is to check whether this composition is 1 or not. This is our requirement, right? Or not. This is our requirement. How we will check this function is 1 or not. Now, there are two cases for there are many cases for this f and g. Like 4 cases are there. If f is 1, but g is not. Second is f and g both 1. Okay, I am writing 1 as like this. Now third is f is not and g is 1. And the fourth one is f and g both are not 1. This is the only 4 cases which will be happen here, right? Right?
Yes, sir.
Yes, sir.
Right? Now,
Yes, sir.
let's check one by one. If you guys have any doubt, please ask. Let's check for one. Now, if f is 1, g is not, then what we will say for this f composition? Okay. Suppose let's take two distinct x1 not equal to x2, and suppose let's equate them. And my assumption is like for this x1 and x2, f of g of x is equal to f of g of x1 and x2. This thing we can say like my initial assumption is this is not 1. So we can say like that. If we will get a contradiction, then we can say, yeah, this is not, this is a 1. If we will not get contradiction, then we cannot say anything. Okay. Now, since f is 1, we can directly write it as like this. Right? Why? Because this is what? F of g of x1 is equals to f of g of x2, right? And this whole thing is input for f, this whole thing is input for x, this whole thing is input for s. You can treat it as like y1 and y2, right?
Yes, sir.
Right? This whole gx1 is can be treated as like y1, and this whole gx2 can be treated as like y2. Since f is 1, 1 and f of y1 is equals to f of y2, then y1 has to be equal to y2, right? Right? Clear up to
Yes, sir.
this? Now, what about this g? Does we can say anything about this g? Do we can say anything about this g? Can we say x1 is equal to x2 from here? No, right? Because g is not 1, 1. Since g is not 1, 1, so now since g is not 1, 1, so we cannot say whether this x1 equal to x2 or not. Right?
Okay.
Please follow me. Okay. Now again you can check, since g is not 1, 1. Okay, this is the another way. From here we have seen that, yeah, after this we don't have anything to show that this x1 is equals to x2 or not. Right? From here we don't have anything to show that from this step to this step we cannot go directly, right? We need some more information about this g, right? From here to here we cannot say anything about
Yes, sir.
this, whether this equality hold or not, right? Now let's go with another thing. Okay, this is the another way. Now g is not 1, 1. Now, since g is not 1, 1, then what will happen? There exists two x1 not equal to x2 belongs to domain of g, such that g of x1 is equals to g of x2, right? Right? This happens that at least two members are there, at least two elements will be there in the domain. For that, g is giving to me the same value, same output. G will map to the same output, right? If g is not 1, 1.
Yeah.
Yes, sir. Yes, sir.
Right? Okay. This is kind of theory, but yeah, it will help you for checking this kind of function. Okay. Now, if this happens, treat it as like y1, treat it as like y2. So you can say, yeah, sir, y1 is equals to y2. Right? Now, this y1 and y2 will work for our f as an input, right? So what will happen? We can say now f of y1 will be equal to f of y2. Right?
Yes, sir.
Right? Since
Because
f is
f
1,
is
1.
1, 1. Yes.
F is 1, 1, we can write it as like this. Everyone is following?
Yes, sir.
Up to this, no doubt. Since f is 1, 1, this will happen. Now, what is
Yes, sir.
this basically? G of x1. Right? I just put this y1 value here and y2 value here. Now, what will be again further step? F of g of x1 is equals to f of g of x2. Right? But
Yeah, right.
x1 not equal to x2. That we have already considered here. So what we will
Yes,
get up to this? We got for two distinct element, we got this, the image of f of g, this composition is equal to each other. It means that f of g is not 1, 1. Right?
Yeah, right.
If f of g not 1, 1, like if g is not 1, 1 and f is 1, 1, in this case, we got this result. F of g will not going to 1, 1. Okay?
Okay.
Okay. Similarly, suppose f is not and g is 1, 1. let's see what will happen. So consider two distinct elements again. Then what will you get? Gx1 not equal to Gx2. Right? Since G is 1, 1.
Yes, yes.
Now again you can write it as y1 not equal to y2. Now what happened when we will apply this f here? They can be equal, right?
They can be equal.
They can be equal. Since f is not 1, 1 possibility. They can be equal. It means that if one of the function from the composition is not 1, 1, the entire composition will not going to be 1, 1, right? 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 If in FOG one of the function from F or G not 1, 1, your f of G will not 1, 1, right? That we got now. If one of the function is
Yeah.
not 1, 1, then this entire composition will not going to be 1, 1.
Yes, yes.
Right? Now what happened? Now one of the that we are saying one of the function. Now if both are not 1, 1, then also this hold, because we are saying if at least one of the function is not going to 1, 1, the entire thing will not going to 1, 1. Okay. The last case that okay. So what are the case that we have done up to this? We have done this. G is not. We have done this and this. Right? Right?
Yeah, right.
Now, what about this F and G? If F and G both are 1, 1. Let us see. Take x1 not equal to x2. In this case, since G is 1, 1, you can write it as like this. G of x1 is not equal to G of x2. Then you can treat it like y1, you can treat it like y2. Then you can say, yeah, if you apply f1, this is not equal to f of y2. Why? Because f is also
Because
1,
F
1.
is also 1. Yeah.
So here from here you can say, yeah, this is not equal to. Okay. So from here you can say f of g is 1. So what is the result here? What is the result is here? The result is says that f of g is 1, 1.
If and only if both the function are 1, 1 individually.
Exactly. If f and g both are 1, 1. See, we cannot say like that. If this is 1, 1, then this f and g both has to be 1, 1. Okay, we are not saying like that. What we are saying if f of g is 1, 1, if this thing is 1, 1, if f and g is 1, 1, here if and only will not going to hold. I will let you know why. Okay, if f and g both is 1, 1, both are 1, 1, then f of g will be 1, 1. Okay. Okay.
Yeah, okay. Okay.
Okay, sir.
Okay. But there is a possibility that okay, you can write it as like this. If this is 1, 1, then f is 1, 1. Okay, but converse is not true. Converse is saying if f of g, this is converse statement, okay? Contrapositive statement you can say. F is 1, 1, f of g is 1, 1, then f and g, it's kind of like more theoretical, but yeah, still you have to know about this. F and g both are 1, 1. Now, before going this, you can easily check this question, right? Where is it? This one. Here, as you can see, f of x is log x, log 2x. Now, here compositions are there. And as you can see, you know that fact that this log 2x is 1, 1. By the graph, by looking the graph is looking like this. This is 1, 1, right? Since your f is
Yes,
1, 1
yeah.
and here you are taking the composition of itself, f of itself, so it's going to be 1, 1. Okay?
Yeah, okay.
Okay. So it will be 1, 1. Easy, not so tough. In the composition case, similarly, you can check the e part, like exponential part if you have some. Okay, let us check if FOG is 1, 1. Then what about this f and g? Suppose you take fx is equals to x square and gx is equals to root x. Okay.
Okay. Got
Okay.
it.
Got the idea? This is not 1,
Yes,
1.
sir.
Domain, you can say
Yes, sir.
what are the largest domain is defined. What about the FOG? Is x, right? This is 1, 1.
Yes, sir. Always one FOG.
Yes, but this is not. This is 1, 1, but this is not. Got the idea? The converse part is not true.
Yes.
Okay. Okay, let's move to that question. What was there? Where is it? Okay, this one. So this one is correct. F is 1, 1. Okay, what about the domain of f? How will you find the domain? I will let you know. F has an inverse. Since it's a 1, 1, it's a 1, 1 function. It will be inversible, right? In the domain of definition, it will be inversible. So f has 1, 1, right?
Sorry to interrupt. Is there a difference between reversibility and inverse?
Yes, the difficulty, like the difference between both of them is like this. See, what is the inverse? There is a result which is tell us that, right, if f is invertible, then f has to be 1, 1 and unto both, right? Right?
Okay.
So
Okay.
reversible function, it means that if a function can be made a invertible function by constraining its domain, then that function is known as reversible function. Okay.
It doesn't specify on the onto.
Not exactly onto, but the thing is, if I will change something in my domain, like if I will restrict my domain and if I am getting some 1, 1 function.
Okay.
Okay. I am getting the 1, 1 and onto both condition, or I am getting invertible function. So that function, initially that function was not 1, 1. If I was taking the whole entire domain.
Okay.
But doing some restriction on it, I am getting a invertible function.
Okay.
Okay. So if I am getting a invertible, but initial that function was not invertible. So in that case, that function is known as reversible function, because after doing some restriction on the domain, I am getting some like I am getting an invertible function. So here, as you can see, this log x, I don't know about its codomain, because I can take codomain as entire real number, but there is a possibility that the or I can take the entire complex field as well as codomain, right? We can take
Yes.
that as codomain because a real number is a subset of codomain. So we cannot specify whether this function is a invertible or not without looking its codomain. Right? But yeah, inverse will exist if I will constrain the codomain and I will do some restriction on codomain or domain, whatever it is. That I am sure, right? So this function has
Yes.
inverse in something, some domain and codomain. If I will restrict that kind of, if I will do some restriction on codomain and domain, this function, the inverse of this function will exist. That was the point. So this two point is satisfied, right? Right?
Yeah.
Right. Now, I have to check this. The domain of the domain of f is what, and the straight line x is equals to 8 will be the asymptote that we have to check whether it will be asymptote. What do you mean by asymptote? if some line is the asymptote of some graph, what does it mean?
It never touch X axis.
Y is equal to.
So it
Means
means
that
It never intersects with X.
no, not exactly. Has you seen this graph e raised to the power x?
yes.
In this case, we will say, yeah, this line x is equals to 0, not x is equal, y is equals to 0. This line is an asymptote of this graph. Why we will say? Because this line, we will not going to see this line, okay? We will not say this line will be the asymptote. But as you can see in this graph, if we will go larger and larger, this line will cross like this. This graph will going to be touch of this line, but it will never touch, right? This graph will going to be closer and closer of this line, but it will not going to touch this line. Or we can say, yeah, this graph somewhere, no sir, it will touch our graph in the infinite, like after infinite step, this graph can touch the graph. This graph can touch this line. That we can say in the infinity, whether, see, since infinity is not defined, we cannot say about it, but yeah, we can say as this line goes to minus infinity, this entire term, whatever this it is, this entire term is going towards this graph, this line only, right?
Yeah.
This line y is equals to 0 only. So here, from here we can say, right, that we can say this, that yeah, this line will touch this graph will touch this line in the infinity. That we can assume at least, right, by looking the graph. Or we can say, as you can see here, this graph, then we will say, yeah, this x is equals to 0 line is the vertical asymptote of this graph. Why we will say? Because as we can see here in this the graph, like the graph of this function, whatever it is, fx, as you can see, yeah, it's feeling like whenever I will go larger and larger here, I will go this direction, this graph will be somewhere touch, looking like it will go to closer and closer of this x is equals to 0 line, right? So in that case, if we will say, if some line is going to touch our graph in the infinite region, in the infinity, then we will say, yeah, that line will become our asymptote. Okay.
Yes.
Okay, sir.
Okay. Okay, understood what does this asymptote mean? So that's what it is asking here. He is asking in this question, where is it? Yeah, in this question, whether the straight line of x is equals to 8 is an asymptote of f or not. That we have to see. Okay, if x is equals to 8 is an asymptote of this f, then what will be, what we can say? X is equals to 8, what does it mean? It means that this is your x is equals to 8 line, right?
Yeah.
Right? It means that this graph, whatever it is, this graph will never going to, this graph will be look like this, or you can say, yeah, it will be look like this, or you can say it will be look like this, or this are the only 4 possibilities here, right?
Yes.
I don't know here what it will be, but it will be go like this is the only possibility, right?
Yeah.
Right? Now we have to see what is the behavior of this graph. Okay, so we have this log 2 of x. What is the behavior of this graph? Okay, so basically what does it means? It means that as you can go x, as you can take your x going towards this 8, your this log 2 going towards infinity. That's what he was asking actually, right? Or
Yes,
minus
sir.
infinity, right?
That
That's
is
what he is asking.
asymptote
Whenever
means.
your
Yes.
x will go to 8, here this graph will go to either plus infinity or minus infinity. That's the only way that you can say, right?
Yes, sir.
Right? Now let's put x is equals to, let's try to put x is equals to 2 here. What it will be? try to put. Okay, I am not saying just directly put, but we are just checking it, what it will be. Okay, so we can write it as 2 raised to the power 3, right? 8. I am putting x equals to 8 here. I am just checking. This is not the exact way to do this kind of thing, but yeah, it's still one of the way that we can see in our mind. Because in the examination, all it's just objective question, so no one will going to ask you what you did in this. Okay, if this is going to be infinite, then we cannot say anything. Okay, so what it will be? It will be log 2 of 3 times log 2, right?
Yes, right.
Right. So this will become your 1. Base
Yes, sir.
and this part both are equal, so this will become your 1. So what it will be? It will be log 2 of 3. Right? Right?
Yes.
Yeah, right.
So as you can see, this is a positive value, right?
Yeah.
This is a positive value. So for the positive value, because why I am like, why I am that much confident that this is a positive value? Because as you can see, graph of log 2 is increasing, first of all, because 2 is greater than 1, so it's
Greater
increasing.
than 1. Yes.
Yes, so it's increasing, and at x is equals to 2, the value of log 2 is what?
1.
1 or 0?
1.
1,
1,
sir.
right? So it means
Yeah.
if say here, somewhere here your 2 is, so here will be 1. So if I will put greater than any number which is greater than 2, this log 2x value is always greater than 1,
Yes, sir.
Yes.
right?
Always.
So it means that this is positive, strictly positive, not even 0, right? Right?
Yes, sir. Yeah.
So it means that this value will exist finitely now,
Yes, sir.
right? Because log 2 of some positive value, this is exists finitely. Because positive, it means that not, see, where this log is not defined, in this region, right? In this region, log is not defined. Minus infinity to 0. In this region, log is not defined. If your something is coming from your this 0 and infinity, then it is defined. It means that it will not going to become infinity at any cost or minus infinity. Right?
Yes, sir. Yeah, right.
So in both case, these are the case will not going to happen. Right?
How do we know that it will not become infinity? Because it is greater than 2. It is going to be greater than 1, but greater than 1 could be infinite as well.
See, in this case, that means I have said this is greater than 0 as well, right? Right? Up to this, no issue, right? So there is a possibility whether you can take x goes to infinity or log 2s goes to infinity. That's true. But here I am restricted x as 8 only, or x as 3. In this case, I am restricted as is equal to 3. So if I will take x is equals to 3 here, so your log 2, 3 will be positive number only, right? Not going to infinity. It's just a number. Right? 1 point something or 2 point something, but it's just a number. That's the thing. It's not going towards infinity because I have fixed this x as x is equals to 3. Right? That's the thing. So if this is just a positive number, so again we have 1 log 2 and we are operating with this positive number. So since this is a positive number and this is positive number, it means that this is lying somewhere this interval. So if it is lying in this interval, the value of log will exist finitely, right? This is some constant c.
Yes, sir.
If this is a positive number, this is some real number only, right? Not going towards infinity or not going towards minus infinity.
Yes,
Getting
sir.
my point?
Yes, sir. Yeah.
Got the idea?
Yeah.
Yes, sir.
Okay, so rather than if the question was not asking like this, if they will say, yeah, sir, just let me know whether this x is equals to 1 is asymptote or not. So what we will say, we have to check this now. Log 2 of x, whereas you can say x tends to 1. We have to see whether this quantity, this log 2x, where it will go. Log 2x will go towards 0, right?
Yes, sir.
Right, because log 1 is what? Log 2 is 0 only. Right, so it
Yes.
will go towards 0. So now this like inside thing is going towards 0, means that this whole thing will going towards minus infinity.
1.
Minus infinity, right? This is what? Log 2x. This is log 2x. Now from here your x is going towards what? 0. Going towards 0. If x is going towards 0 and its graph is looking like this, so if x is going towards 0, this is your 0 line, right? So it means that your x is going towards minus infinity only, log x.
Yes,
Yes,
sir.
sir.
Right? So it means that this entire thing will go towards minus infinity. Now, what about this log 2 of minus infinity? What we can say anything? Can we say anything about this?
Nothing. Nothing.
Not
Nothing.
defined.
Not defined. Yes, sir.
Okay. So from here we can say x is equals to 1 will not become an asymptote because we are not going to define this kind of situation as well. Right? So for that we need its domain. For checking this, which value we have to take for asymptote, we need to check the domain. So how will we check the domain? That's our point. Right? Okay. So my question is, if you have this log AB criteria, then what are the criteria of this A and B? A, B, X or AX you can say. So the criteria is A is greater than 0, first of all. Right? A is strictly greater than 0. No matter A is 1 or whatever it is, no, doesn't matter. But A has to be greater than 0. This is one criteria. And X is what? What are the criteria in this X? This also is strictly greater than 0, not equal to 0 as well. Right?
Yes, yes.
This is the criteria. Now, whenever you will get any function in terms of log, any function fx in terms of this log, here somewhere here base is there and here something is there, okay, in the input section. So you need to apply this to two section. It means that suppose this is your gx in your base and fx in your hx in your this input value. So gx is a n function of x, hx is here a function of x. So you have to apply this gx is greater than 0 or as well as hx is greater than 0. These two conditions that you have to apply. Okay, for example, if I will take fx is equals to log x plus 3 here, and here I will take x square minus 4 divided by x minus 2. If I will take this equation, now if the question they will ask in the question, right, find the domain of this function. So what will you choose? You have to see both of the condition. So this base has to be satisfied this condition is strictly greater than 0 and this x square minus 4 divided by x minus 2 has to be strictly greater than 0, right?
Yes, sir.
Right? These two conditions that you have to satisfy. Or you can, in this case, just let's take x minus 3. So it will be more clear to you. Right? Now, how will you check? From here, you can say, yeah, your x will be greater than minus 3. And remember this and sign here. Okay. So from above, what you can say? X minus 2, x plus 2. And the return part is x minus 3. Okay. Now you need to solve this inequality. From here, you can say, yeah, x is coming from minus 3 to infinity. Now, how will you check the inequality? How will you check this? for what value you need to take. Like this is the only portion where you will get you got stuck if they will ask that kind of question, right? If someone is not from a maths background, they don't know how to solve that kind of inequality, right? Right? If rational functions is there,
Yes.
so that's right, right?
Yes.
Yes.
So you can firstly you can go for cases, right? If the both the denominator or numerator term and denominator term both have same sign, then you can say, yeah, sir, you can go by this. From here, you can say x is not equal to 3. That you can easily see because of this denominator, right? Now, how will you
Yes.
check this kind of thing? So just make a real line here and see what are the points for what your this function is going to be 0 or infinity. So here you can see 2 is the root of this function, the denominator numerator term minus 2
Minus
and 2
2.
is
T.
and 2 is the root of this this numerator term, and then write the root of this denominator term as well. So what is this? 3, right? Just
Yes.
write the roots of just put the roots of the numerator term in the real line and denominator term real line separated. Okay. Now apply wavy curve here. So wavy curve, how will you check? If x is greater than 3, just observe here. If x is greater than 3, as we will check on the polynomial thing. As x is greater than 3, the denominator part will be positive, right?
Yes, sir.
It's a
Right?
whole term will be
Similarly, the numerator term is also positive.
Yes.
Now, so if this thing is happen, it means that here your function will be positive. Function will take positive value in this reason.
Yeah.
Now see the multiplicity. Here you are in 3. Just see the multiplicity of x minus 3. It's 1.
Yes.
So it will cross.
Yeah.
So here the function
Yeah.
will take negative value.
Negative value.
See, the graph will not going to become like that, but yeah, we are estimating like function will take positive value or negative value. Okay.
Yeah.
The graph will not going to like this. You cannot say, yeah, sir, graph will look like this. No. We are just estimating what are the value function will take. The function will take positive value or negative value. That we are saying. So firstly, we will start from the right hand side. We will say, yeah, see the like last point, whatever you have here, we have 3. Then we will check if I will take x is greater than 3, then what will be the sign of your function? So if the sign of your function will be positive. Now, just see the multiplicity of 3. If this is, since the multiplicity of 3 is 1 here, so the function will cross this axis and we will say, yeah, the function will get negative value here. Okay. Okay. Now move towards
Yes.
2. Move towards 2. Now, what is the multiplicity of 2?
1.
in 1.
1. So here function will take positive value. Similarly, move towards minus 2. What is the multiplicity of minus 2?
Again 1.
1.
1. So here it will take minus. Suppose here if somewhere here x square was will be there, then this will not going to like this. Okay, because the multiplicity is 2, then function again will take positive value. Because
Positive.
in the polynomial
Yeah.
thing we have observed the thing that yeah, this function will go like this. But this is not the case here because this is a rational function. Okay, you understood the point what I am trying to say?
Yes, sir.
Okay, easy, not so tough. Okay, so just collect the reason where function is going to positive in this region and then in this region, right? We are just taking
Yeah, right.
open interval because if I will put 2 minus 2 or 3 here, the function will either become 0, the whole thing either become 0 or it will become infinity, right? So we will exclude the minus 2, 2 and 3 points from here. So what we will get? For here, we will get x is coming from minus 2
Minus
to
2 to
this
2.
region and this region.
Yes.
Union
3 to
3,
infinity.
3 to infinity, right?
Yes, sir.
This is the case. So basically what it is, your x is coming from minus 3 to infinity, intersection of this minus 2 to 2 union 3 infinity. Okay, because of this and sign. That is why I am saying, yeah, you just remember this and sign here. Right?
Yeah.
Understood up to this? If you have any doubt, please ask, because that kind of question they can ask in the exam. That is very important to you guys. Because from the logarithmic part, that kind of question only they will ask. They will not going to say, yeah, just make the graph of log of x or
Yes,
whatever
sir.
it is. Yes.
Sir, could you repeat the last two steps, please?
Last two step from this one, right?
Yes, sir.
This graph, this real line part you understood, right?
Yes, sir.
Understood? So how will I go from here to here? See, here end thing will happen. So this is I have directly right here. So how will I get this minus 2, 2? So since I need the positive thing, the greater than 0 thing. So from where my function is getting positive value? In this region and in this region only, right?
Yes, sir.
Right? So I wrote, because I cannot take this minus 2, 2 and 3 value here, because if I will take minus 2, 2 and 3 value in this case, either function will, this whole thing will become 0 or it will go to infinity or minus infinity. Right? So I cannot take that value. So I will exclude minus 2, 2 and 3 from here, and I will say, yeah, in this region or in this region, where will the function value, the x will go, the functional value will be positive. This value will be positive. If I will take x from here or here, then functional will be positive. It means that s can be coming from minus 2 to 2 or 3 to infinity. Or you can say, yeah, your x is coming from minus 2 to 2 union 3 infinity. Understood up to this?
Yes, sir.
Because of this and here, you need to take the intersection now. Why? Because the x has to be satisfied this condition and this condition both. It means that x has to be there and x has to be there also. Suppose this is your set A and this is your set B. And what are the condition? X has to be there A inside A and x has to be there inside B. It means what? It means that x is coming from A intersection B only. That is why I took intersection here. Okay?
Okay, sir.
This whole thing is your intersection. Now, how will I check this intersection? Because this is looking like a complicated thing. How will I check? Again, just go the real line in the both. We will take help from the real line. Just draw this point minus 2, 2 and 3. What are the three? Okay. Now draw this region. I will use the different color. What is this region? Minus 3 infinity. Minus 3 infinity is this region only, right?
Yes, sir.
Right? Now, what about this minus 2, 2? This minus 2 to this region. And since I am taking union, so I can use this red color as well. So I am taking this. Right? This is the reason. Now I need to take the intersection part. So what will be the intersection part? This part and this part is only the intersection.
Yes, sir.
Right? So what will be x from where you will take your s? Minus 2 to 2 union
3 to
3
infinity.
to infinity. Okay, so this will become your domain of this function. Got the point?
Yes, sir.
Okay. Is there any doubt? Please ask. That kind of question they can definitely ask. Okay, finding the domain of log of something, or and some they can ask. Okay. If you have some doubt, please ask.
Sir, in
Suppose-
activity 6.1, there is a school of literature.
Yeah, activity
Sorry,
6.1. Yeah, I
Yeah.
will let you know that one. But firstly, I will finish this. Okay,
Okay,
let
sir.
me finish
Okay.
this. Where is the question? Okay.
So question is same.
So-
In log x plus 3 divided by x plus 1, something was there in the same question.
Okay. So okay, I will just take after this. Okay. So let me see what will be the domain of this function. Okay, you guys will tell. what will be the domain of this kind of function? Okay, you have log of 2, and log of 2 here. What are the criteria? Suppose firstly we will take this function log of 2, the outer function. Okay, so this base has to be greater than 0. Here 2 is fixed and it is greater than 0. No condition will apply for this base. Now, what are the thing inside of this log? Inside of this log, it has to be greater than 0, strictly greater than 0, right? Right?
Yes, sir.
Please answer.
Yes,
This whole thing, if I will say this is y, then this y has to be strictly greater than 0, right?
Yes, sir.
yes,
Right? Now, what is your y here?
Greater than 0.
It is greater than 0. Right? Right?
Yeah.
Yes, sir.
yes,
Okay. So suppose I have this y is greater than 0. So I can apply then 2 raised to the power y is greater than 2 raised to the power 0 because 2 is increasing function. Like 2 raised to the power x is increasing function. I can write it as like this. So basically I need to solve this inequality. So how will I solve? So if I will apply this function in this case, so basically what I am trying to say, if x1 is greater than x2 and f is increasing, then fx1 is greater than fx2, that you know.
Yes, sir. Yes, sir.
Right? If f is increasing. So similarly, since 2 raised to the power fx is equals to 2 raised to the power x is an increasing function, right? Right?
Yes, sir.
So here you can apply since y is greater than 0, it means that 2 raised to the power y is greater than 2 raised to the power 0.
Yes, sir.
So what does it mean? It means that from here you can say what is the value of y here? 2 raised to the power log 2 of x is greater than 2 raised to the power 0. That you can see, right?
Yes, sir.
Okay. So what is this? If here 2 raised to the power log 2 of something is there. So what it will be? It will be this something only. Right? There is a case now, if a raised to the power log of ax is there, then it will equal to x base and this thing is same. This is a rule, right?
yes,
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 sir.
In the week 7, there are some rules. I will. Yes,
yes, sir.
someone was
Because
asking.
because exponential and logarithm are the inverse of each other.
Exactly, inverse of each other. Right?
Sir,
So
sir,
from here,
2
what you
power,
will get? Yes.
sir, 2 power 0 becomes 1. Huh?
Yeah, it will become 1. I will write in the next step. So this thing will cancel out. What will you get? Log of 2 of x is greater than 1.
Yes, sir.
Right? Now again apply that 2 raised to the power something. So what will you get? Because 2 is an increasing function, you can write it as like this, 2 raised to the power 1.
Yes,
So
sir.
what it will be? X greater than what? 2.
2.
Right? So for what is the condition for x? X has to be greater than 2. So it means that x belongs to what?
2 to infinity.
Right? Right? This will become your domain of the given function. Okay? Understood?
Yes, sir.
Yes, sir.
Okay. I'm again saying please practice and please try to do the practice assignment by yourself. Okay? So I hope this domain finding thing will be clear for you now.
That means the base is becoming the domain, sir, starting.
Base is not base
Not
is
all
becoming
base.
to the
Not
domain.
always.
That is not exactly true. Okay. Why it is not true, I will let you know. Okay. Suppose I will give you the function fx is equals to same thing. Log 2. I'm taking 4 times log 2 here. Okay. Now I need to find the bases. So firstly, I will go by this law, the like the whatever thing is here, the last thing. Okay, what is the last function here? Log 2x. So in this case, the entire what are the thing is there, it has to be positive. This is another example. Has to be greater than 0, right?
Yes,
This
sir.
input thing has to be greater than 0. Now apply 2 raised to the power something. So what will you get? You will get this log 2x 2 raised to the power. It should be greater than 2 raised to the power 0. What does it mean? Means that 3 log 2 are there, right? Okay. What does it mean?
Why did we
this
apply
log,
this 2? Why did we apply this 2?
because of this base, I just want to remove this log thing here, and I
Okay.
just want to get the condition in this x.
Okay. So if it would have been log 4, then I would have raised 4 to the power.
Yeah.
Yes.
Suppose here log 3 is there. Suppose that here log 3 is there. This is what? This is log 3 is there.
Mhm.
Okay. Now what I will do? So from here I will get log 3 log 2x greater than this one. Okay. Now 3 is there. I will apply the 3 power. So what I will get? 3 raised to the power log 3. That can also happen. Okay. 3 raised to the power 1. So what it will be? It will be log 2x greater
Is greater
than
than
3. Now again apply this 2 because of this base. So
2 to
what
the
it will
power
be?
2 plus 2.
So what it will be? X has to be greater than 2 raised to the power 8. What 2 raised to the power 3, which is 8. So what will be your domain? X is coming from 8 and 0.
To infinity.
What the idea? What are the things are there? Because I just want to remove this log thing, no? Or you can say I am taking the inverse part of this log thing. What are the thing is there in the base? Just take the power of that. Understood the idea
Yes, sir.
behind this? Okay. Rather than this x, they can say x square plus 2 as well, or x square minus 2 as well. Okay. Now if x square minus 2 is there, here you will get x square minus 2. Now you need to solve the further thing, which is be x square minus 2 minus 8, which is greater than 0. Then it will be x square minus 10 greater than 0. Now here you will get 2 points, minus root 5 and plus root 5. Now you need to check the domain where this thing is greater than 0. Root 10, sorry. Okay. Now mota thing is you got the idea. How will you check? Now in this case, what will be the domain? This domain and this domain, right?
Yes, sir.
You got the idea. How do we check the domain thing?
Yes, sir.
Yes.
Okay. Someone was asking some question from the activity. Can you please repeat it again?
So 6.1, question number 4, I think.
0.1. This one. This is the same question that was I have explained. How will you solve this question? Okay. Okay, we will solve by here itself. Okay. You guys please try to solve this question. I will give you two. I will give you okay. I will give you 3 minutes for this question. Everyone please try to solve this. X plus 1, x minus 1. Sorry, x minus 1, x plus 1. X minus 1, x plus 1. Okay, this is in the base. And what is there in the input thing? X square plus 1, x square minus 1. X square plus 1, x square minus 1. Okay, find the domain. Okay, I will give you 3 minutes. I will ask this thing in 9:50. Okay, you just give me the good. Did anyone solve that? Hello?
Yes, sir. R minus close interval minus 1 to 1.
R minus close interval 1 to 1.
Minus 1
This
to 1.
one. This one, right?
Yes.
Okay, let's see. Is there anyone who solved this?
Sir, solving.
Okay, if someone has solved and got this answer, please write Y2 in the Y in the text box, or they can thumbs up if they can. I cannot say please.
-1 and 1 is not included here, na?
We will check. I did not solve yet, na. I will check. Here, see, because I am
Yes,
minusing
sir.
this. Okay. Yes. I am minusing this kind of thing. So here you will say this side you can see. Here I am not including this close entire thing, because basically here if -1 is there, 1 is there, so you are getting this interval only, the open thing. So this is what basically this is equal to this union of 1 to infinity.
Yes.
Sir, but then 0 should also be excluded, huh?
So I am
From
getting
here 0 is not there, na. 0 is here somewhere like this.
Yeah, it should be excluded.
It's already
It is
excluded in this
already
domain.
excluded.
Okay, I consider.
We will check what thing will be going to happen. Okay, that we
Sir,
will check.
I got 1 to infinity. X belongs to 1
Okay,
to
okay.
infinity. Open
Okay,
interval.
okay, Mohammed. We will check. We will check. Okay, Krishnavani also get this 1 to infinity. We will check. Okay, let's try to solve this. This question will help you to like this. The question will give a better understanding. Now, what are the things there in the base? X minus 1 and x plus 1, right? For this function has to be the kind, it has to be greater than 0, right? And remember this and sign here, because x has to be satisfied for this and this simultaneously, right? So it means that the base thing has to be greater than 0, and the whatever thing are there in the input thing, it has to be greater than 0. So it means that x square plus 1 minus x square minus 1 is greater than 0, right? Is there any doubt up to this?
Yes. Correct.
No, sir. No, sir.
See, I have a
No?
small doubt here.
Yes.
See, because
Yes,
we are
yes.
insisting that x square plus 1 by x square minus 1 should be greater than 0. And I had this doubt in my earlier case, the problem that I showed you first. I posted it. There e minus 100e, you see. So isn't that a negative value?
Sorry.
Oh, this is for
Minus
log, that's for
100.
exponents.
This is for log. For e, the case is separate. For e, we can take any input value, right? There is no constraint in e raised to the power something. So always, if e raised to the power something is there, the domain should be
okay. No,
real
for
number
exponents,
only.
is there any condition like this? I mean, it should be greater than 0, something like that.
No,
A should be greater than 0.
If a raised to the power fx kind of thing, then fx can be come from any real number. Fx can be any real number, now, because the graph of e raised to the power x is looking like this. No?
Okay.
Here
No, but
you can take any value.
But we had minus 100 e something, e to the power something, isn't it? So that minus
Whatever thing is there.
Yeah.
It is 50 minus 100 e raised to the power minus 0.2 t. Whatever thing is there.
What is it?
Yes. Whatever thing is there, what I am saying, whatever thing is there. See, this thing will not going to play any role in the domain kind of thing. Okay.
Oh,
the main thing is, because this thing is always defined. The main thing is this part. We need to check in this part whether this function is defined or not. But as you can see, this is e raised to the power something.
Yeah.
So what is basically e raised to the power 0.2
this is
t?
defined.
This is right.
This is defined. Yes.
This is right. So now I need to if this function, this e raised to the power 0.2 t is going to be 0, then this will not going to define. But the thing is, this will not going to become 0, because this graph is looking like this denominator graph. It will not going to 0 at any case. Okay, so this is always divided. So it means that yeah, t is coming from RT can take any value.
Okay, but so but that minus 100 doesn't really change
Yeah,
our.
This can play in the finding the range kind of thing, but this cannot play the role when we will find the domain. So basically, in the domain, the largest domain, we need to check the restriction. What are the restrictions we have in the function?
Okay.
Here, what we are checking basically? We are checking the restriction now in the log
I understood.
AX kind of thing.
Okay.
X kind of thing. We have restriction AX should be greater than 0, X should be greater than 0.
Yes.
That's the thing. That's what we have applied here.
All right. Thank you.
Okay, so
Thank you.
these are the thing
Sir?
has to be satisfied, right? Yes.
Sir, in that exponential function, how will minus 100 affect the graph of e power minus 0.22?
Okay, that I will explain after this. Okay, how will this
How will
translation
that
of graph will
shift
work?
the graph?
Shifting
if
of graph,
constant
that
is
I will say.
multiplied or
Oh yeah,
negative
that I
value
will
is
say.
multiplied?
Yeah, that I will say. Just wait for a second. Okay, now we will check this. So what will happen? So for this, we also need the real line thing. And for this also we need real line because here numerator and denominator terms are there. So here, what are the root for numerator? It's 1, right?
1. Yeah.
What about denominator? It's -1. Again here, what is the root of this x square plus 1? See, here this x square plus 1 is always going to positive. And what is the root of this? Nothing is there.
Root -1. Yeah, actually complex number.
Minus I, complex number. So this will not going to play any role because the
Yes, sir.
roots
It
are
will
complex.
take a whole real number. Yeah.
Yes. So it will not going to play any role. So we will go through check the denominator path. What is the roots of denominator thing? It's also -1 and 1.
-1 and 1. Yeah.
Right now, for this case, this has to be positive. Now, if I will take x greater than 1 value, it means that I will take any value from here, x greater than 1. The numerator part will be positive, the denominator part will be positive, right? It means that in this case, this thing will be positive only.
Sir,
In
I
this
have a
reason, this
question.
function will be sorry.
Sorry, sir, to interrupt you. I have a question, sir. So on the right hand side, you told that x has two roots. That I got it. That it will be -1 and 1.
This one.
The below denominator one that you told, sir.
Yes. Yes, this is -1 and 1.
Yes,
How
sir.
will I got?
No. That I know, sir. But I have a question. Like, if it is 1/0, then it will be undefined now.
1/0, it means that if x is equals to 1 and 1, this one. See, I am checking this denominator separately as x square minus 1. I am not checking this 1 by x square minus 1. I am just checking this part. And here I am not making the graph of this function. See what I am trying to say. Here I am not going to make the graph of this function. I am told you initially that I am just checking the what will be the points. I am agree that if this will go to -1, but if the what I will say definite basically this is suppose this is your -1 and this is your 1. So basically, if the denominator part is going towards 0, now from which direction this graph is going to 0, that's important. From the negative direction or from the positive direction. What does it mean? Means that, see, if this will going to 0, that I am agree that, yeah, this whole thing will going to infinity. But from which direction it will going to infinity? Whether this going to this way or whether this going to this way? That's my question. What the idea?
Okay, sir.
Okay, if this is going to this way, it means that this is what? Negative thing. If this is going to this way, it means that what? It's a positive thing. Right?
Yes, sir.
So basically, that's what I am trying to say. Or basically, I am not interested in the making of graph. I am just interested in the sign of this entire thing. What will be the sign? Okay.
Yes,
okay. Now, here. So if I will put any positive value greater than 1, this function, this entire thing will be positive only. So here, this will here function will be positive. Now again, What is the multiplicity of 1?
1.
1. So here function will take minus value. Now move towards -1. What is the multiplicity of -1? 1. So here it will take +1. So from here, as you can see, x can be take value from -infinity to -1 union 1 to infinity. Right? Here, let's look towards here. Now, if I will take any value which is greater than 1, what I will get? What will be the sign of this function? Positive, right?
Positive, yeah.
Right? Why it is positive?
Yeah,
Because
right.
here entire in the numerator part, whatever value you can take, you will put for the x, it will always be positive. The thing is, this denominator thing will decide whether this whole thing will be positive or not. So let us see. This x square minus 1 is what? This is nothing but your x minus 1 and x plus 1. So from here also, as you can see, if I will put x is equals to x is greater than 1, so this thing is positive. And since this is also positive, so this whole thing will be positive. So here function will be positive value. Again, let's see. What is the multiplicity of 1? It's 1. So it is negative. And similarly, here as you can see, you will get this interval positive.
Sorry, I'm just a bit confused. X square plus 1, whatever value x, it's going to be positive, isn't it?
X square plus, yes.
See, x, even if x is -5, even then it will be positive only, isn't it?
Yeah, because -5 square is what? 25. And
Well,
plus 1 is 6.
Correct. So, so that is why you're including on the left side. Okay, all right.
Exactly. Got the idea. Now, from here, what will be the x input value of x? Same. Union 1 to infinity. Okay. Now, we need to take the intersection. So, basically, what it will be? X will come from this. Suppose this is your set A, this is your set B. So, it has to be come from A intersection B. As you can see, both sets are equal to each other. Right? So what will be the intersection? The intersection will be -infinity to -1, union 1 to infinity only. This will become your domain. Or someone will say, yeah, this is nothing but R minus this closed interval 1. Okay?
Yes.
Okay, got the idea. So what will be the answer for this question? This one. I have already select the answer.
So why -1 to 1?
Yeah. The thing is here, this 1 is not included. Okay, this is incorrect thing.
No, even sir, sir, it cannot be -1 to 1 because it should be more than 1, no?
Sorry.
Okay,
Is
sorry.
there anything that I commit mistake in?
All options are incorrect, right, sir? Under?
Yeah, here all options are incorrect. You can you can complain about this question like all options are incorrect here. Okay, so that this is not graded, right? So no need not to be worried about it.
Sir,
No, it's incorrect. It's incorrect. All options are incorrect. Okay, there are no function. He is saying there are no functions.
Yes, sir.
Okay, so it will be this one.
Sir, it is asking.
Okay, there are no functions. Okay, so
functions
question
of
is correct. Okay, what was your doubt, Bhumika?
Sir, I got sir, that it was -infinity to -1, na? And then 1 to infinity. But you told that it will be -1 to 1. So it will not include then infinity, like positive
Sorry,
infinity 1.
where I wrote this one I have wrote, no? This is the domain.
Yeah, sir. But then I thought that you are writing only -1 to 1. But I
No,
didn't
this
saw
is
that.
this thing here. I have wrote R minus this thing. What does it mean?
Yes, sir.
Means that
That
if
are
-1 and 1
excluding.
is there, yeah, I am excluding this interval on. Okay, I am excluding this
sir.
interval, then I will get this interval only.
Yeah, I didn't saw that, sir. Sorry.
Okay.
Sir, going to that question again. If you can bring up that screen. Yeah. Then the first option also will be for which the function will not be defined, right?
Exactly.
And then the
For
last option
0.
and last option as well.
Yes.
All
Yes.
okay.
This one also, I guess. All the 4 options are correct in this question. Okay, got the idea basically. What was the okay? What about this fifth one? What will be the domain of this fifth one? What is the question?
So for the above question,
yes.
So if you can go to back to the question before this one, 3, question number 3.
Yes.
I solved it and the roots were like 5 and 3. But why did we raise it to 10 to the power of 3 and 5? I didn't understand that.
This one. Okay, this will also I will take. Okay. Oh, how will I solve this? Firstly, I just let me know how will you solve this.
Sure.
Log of minus of x e raised to the power 3x. Quickly solve this question and let me know the domain. Okay. Let me know the domain. Quickly solve this question. Same procedure will be there. See, if something is not there in this base, suppose you can take e or base 10. Base 10 basically. In the case of log and in the case of ln, it's base e. Did anyone solve that? Anyone has done this? Anyone?
Sir, minus
Yes, sir.
infinity to 0?
Minus infinity to 0. Yeah, same.
Anyone got this? Not sure why the previous question, all the answer is incorrect. Abu, he was asking from where the function is not defined. So as we can see, the function is defined in this interval only, no? In this interval only the function is defined in this set. So here, as you can see, this set will contain the points from -1 to 0. So between the point -1 to 0, this function is not defined. Similarly, here it is containing that exclusion set, not defined. 0, it is containing 0 as well. From -1 to 1 also it is not defined. If at least one of the points are there inside the set for which this function is not defined, then that option will be correct. So we are finding that point only. So here, as you can see, -1 and 1 are the 1 and 0 are those points. So here -1 and 1 play that rule. Here 0 will play the rule, that rule, and here also 0 will play the rule, and here -1 and 1 will play the rule. Okay, let's discuss about this question. So similar thing is there. The this thing, what are the things are there, because base is positive, either it is 10 or e, it is positive, so we need to worry about this thing only. So what it will be? It has to be greater than 0, right? If I will multiply minus here, so what it will be? It will be x3 raised to the power x minus 27x less than 0. No, what it will be? Right? Right?
So I didn't
Yes,
get
sir.
a second step.
This one.
Mm.
I just multiply whole the equation by minus. So if I will multiply minus for this equation, the inequality sign of inequality will change, right? How will it change? Suppose minus 4 is less than minus 3. This thing is happen in the real line, minus 4 lying here, minus 3 lying here. Right? Now, if I will multiply by minus sign in this equation, what I will get? 4, 3. Now, what it will be? 4 is greater than 3, no? The sign will change.
Yes, sir.
Got it?
Mm.
Because this is all this is what this is also a real number for a fixed value of x.
Yes, sir.
Okay. Now I need to decide for this. Okay. Similar thing, I have to check the roots. What is the roots for this? 0. What about this thing? What will be the roots? It is what?
X should be less than log 3 base e.
This is thing, this thing, right?
Yes, sir.
This is what? Right? Right? So you can write it at e raised to the power x whole cube is equals to, okay, since fx is equals to, again the same thing, x cube, fx is equals to x cube is a what? 1 function, right?
Yes, sir.
Yes, sir.
Is that if fx1 equal to fx2, then x1 has to be equal to x2. So here, this is your x1, this is your x2, so it means that e raised to the power x has to be equal to 3. Right? Right?
Yes,
Please
sir.
answer, no? Then only I can understand
Yes,
you
sir.
whether you are understanding or not. Okay, so from here, if you solve this, you will get x is equals to what? Log 3, or you can say ln 3.
Yes, sir.
So what is the roots of this equation? Log 3. So log 3 is here. It is positive, that is why I am writing here. Okay. Log 3
Okay.
is the root.
If
It
we,
means
if we are
that
writing log, then we have to write base e, right?
yeah, you can say
Log 3
here
base e.
in this case, I guess it depends like what the author is taking. Like sometimes the people will take log base 10 here. Sometimes they will take for log e.
No, sir,
They
but
will
we
take
got
ln
e to
here.
the power of x equals to 3. So if you are
Yeah.
changing that, then it would become
Base
ln
should
e
be
equals
e.
to 3.
Okay, log e, that is fine. Yeah, you are right. Here ln 3 we have to write, or log e. Okay. Let's take ln. Okay. Now it's correct.
ln is base e or base 2?
ln is nothing but
Always.
this log e, base e, natural log.
All right. All right.
Now, see this whole thing. What I am saying, if x is greater than this ln3, what does it mean? It means that e raised to the power 3x is greater than 27, right? Right? Because e is an increasing function.
Yes, sir. Yes.
E raised to the power
Yes,
something
yeah.
is an increasing function. This thing will happen. You can apply this both sides, then you will see, since it is an increasing function, then e raised to the power x will greater than ln is what it will be 3. Then again take 3 powers because it's x cube also an increasing function, then you can say like this. So basically what does it mean? It means that e raised to the power 3x is greater than 0. So basically what does it mean? It means that this whole term will be positive if I will take x greater than ln3. So here the function will be positive. That's what I am trying to explain. Okay.
Yeah, right.
Okay. Now, if you will go, the multiplicity of this thing is 1, but here we are not going to see by the multiplicity. Why? Because this is not a polynomial function. We have to worried about it. We have to take care of this thing. Okay. So how will I check? I have to check by this way also. So if I will take any value from here, it means that it is greater than 0 and less than this ln3. So if this is greater than 0, it means that this term is positive. Right?
Yeah.
Right? I need to check this. So in this case, this is negative. Why? If x is less than 3, same thing will happen. ln3. Same thing will happen. Because all are increasing function. Right? So this whole thing, e raised to the power 3x minus 27 will be negative. So it means that from here, function will take negative value. Okay? If something is less than ln3, function will take negative value. Now, if I will take x is less than 0, this term is negative. This term is also negative because you are taking x less than ln3. Means that this negative, the multiplication will be positive. So here the function will take positive value. So what I got? 0 ln3. Here I got positive value, here I got negative value, here I got positive value. But I need only negative things. This. So what will be the domain? The domain will be 0 to ln3. Okay? Okay? Understood?
Yes, sir.
Okay.
Any doubt? Any doubt here?
No, sir.
Right? Everyone? If you guys have any doubt, please ask.
Yeah, fine.
Okay, what about this question? I will give you the hint of this question, okay? So basically here, as you can see, this is kind of quadratic function if you will put in the inner term. If you will put log 10x is equals to y something, the inner term will be y square minus 8y plus 15, right?
Yes, sir.
From there, you can solve that quadratic equation and you can find where the quadratic equation will be positive in which domain.
Right. I got 3 and 5 in that case. Right. So, but I don't know why 10 to the power of 3 and 10 to the power of 5 is there. That is what is my question.
Okay, shall I solve this question? Or I will leave the question. So I cannot, like before solving the question, I cannot say why the things are coming. This is maybe incorrect. Okay, I just put randomly. I don't know what is correct or incorrect. Okay, what is the question? Can you repeat it again? Fx is equals to, another question. Fx is equals to log 10 of what? It is log 10 of log 10 x whole square then minus 8 log 10x then plus 15. This is your question, right? And you need to find the domain of this question. So basically, same thing. The inner term has to be positive. It means that log 10x square minus 8 log 10x plus 15 has to be greater than 0. Now, put log 10x is equals to y here. What will you get? You will get y square minus 8y plus 15 is greater than 0. You need to solve this question. What will be the root of this equation?
3 and 5.
The 3 and
3
5.
and 5.
Minus
Okay,
3
so
minus
basically what will you say? Y minus 3 and y minus 5 has to be greater than 0, right?
Yes, sir.
Just put the value. This is the thing,
Okay.
right?
Mhm.
Now,
Now we will have to raise it 10 to the power of log 10. To get rid of log 10, we have to raise to the power
so
of 10.
yeah, exactly. So here basically, what will the root? Root basically we need to find the value of x for which this thing will be equal to 0. It means that you just equate it. I am finding the root. This is not the root. This is the root of this. I need to find the value of x if I want to find the root. So what it will be? It will be x is equals to, if I will put 10 raised to the power something, so it will be 10 raised to the power 3 and it will be what?
10
10
raised
to
to
the
the
power
X
5. 10 to the
10 raised to the power 5. Okay, so basically the roots of this function and the whole entire thing is 10 raised to the power 3 and 10 raised to the power 5. So if I will write here, so here will be 10 raised to the power 3, here will be 10 raised to the power 5. Now I need to check if I will put something which is greater than 10 raised to the power 5. So since this log thing is increasing function, it means that the entire thing will be greater than 5. Similarly, here this entire thing will be greater than 3. So the whole thing will be positive. It means that here the function will be positive. Right?
Yes, sir.
Yes. Similarly, 10 to
Right?
the power less than 10 to the
Suppose,
power 3, both will
okay,
be negative.
if you are not able to see directly, you just put x equals to 10 raised to power 6. 10 raised to power 6 is greater than 10 raised to the power 5. So if you will put here, so what will you get? You will get log of 10 into 10 raised to the power 6 minus 3. Similarly, log of 10 and 10 raised to the power 6 minus 3. So 5. So basically what it is nothing but 6 minus 3 into 6 minus 5, right? Positive, right? 3 into 1.
Yes, sir.
So basically function will be positive. Similarly, if you put here, the function will be negative. Here, function will be positive. You need the positive value. So your domain of definition is minus infinity to 10 raised to the power 3 union 10 raised to the power 5 to infinity. Simple. This is the answer. This one. Got it?
Yes, sir. Thank you.
Yes, sir.
Okay. Is there any doubt? Please ask. I will close this session by 11, okay? I don't want to waste your time. I think a sufficient thing is covered up to this. Like most of the portion that the graph, like this one thing was required, and the most important thing was domain finding things. So I guess domain finding thing is clear to everybody. Sir, 5
Sir,
questions. Which 5 questions, Suraj?
yes, sir. In this activity only, the question number 5 we have discussed earlier before this
Yeah,
question.
Yes, sir, this one.
Yes, sir.
This
Why we are not taking the value less than 0? in the domain.
less than 0, right? Because
Yes.
here we have solved. Here we have solved. So we have x as multiplication in the entire thing, right? So we have to see the roots of this equation, this function as well, bro.
Yes, yeah.
We have to see the multiplication thing as well. So here the function is going towards
Okay.
positive, because if this is negative, this is also negative, the multiplication of both
Yes,
things
the
will become
multiplication will
positive.
be positive. Okay, okay.
So this
Got
will
it.
become positive. So we can take only this solution.
Oh, okay. Thank you.
Okay. So let's discuss something in translation of graph. Okay, translation of graph, it means what? How the graph will look like this is just the basic thing. What are the things that you have required till now that we will discuss? Suppose you have a function of fx. Okay, y is equals to fx is your graph of the function. Then what will be the graph of y is equals to fx plus h? And someone will say, yes, sir, what will be the graph of fx plus h? These two condition. This is what that you want to know from my side, right? And if you have y is equals to minus of fx, what will be the graph? If you have y is equals to f of minus x, what will be the graph? Right?
Yeah, that would be nice.
Okay, if something
And
is
even
also there.
and even for f of say nx or something like that.
Yeah, this kind of thing, if I will
Yeah.
multiply some alpha of this, so what will be the graph? This is the basic thing. Okay, so let's move to one by one. So here plus minus thing, h can be positive and negative both, okay? So let's discuss firstly this. What is basically. So suppose your graph fx, I am taking just a simple graph x plus 4. Okay, this is your fx graph. Now I am adding fx, I just want to see fx plus 5. So it is nothing but x plus 4 plus 5, right? Now, initially, what will be the graph of what will be the graph of fx is equals to x plus 4? What will be the graph of this? When x is equals to 0.
It's straight line. Yeah.
This
Y
is this kind of
intercept
thing,
will be
right?
4.
Yeah.
This kind of graph is this. This is right.
No.
X, no. If x is equals to 0,
Increasing
y is equals to 4. This. If y is equals to 0, x is okay. No.
It will be increasing.
Yeah,
as
because
well.
yes,
This one.
the slope will be 1. Yeah.
Okay, this is the graph of this function. Now, I am adding this by 5. What does it mean? I am adding this whole thing by 5. Suppose this is one number. Suppose this is k. Okay, and this k is lying somewhere here. If I will add this k by 4, this will move by 4 step this direction, right?
Yes.
And here you will get k plus 4. Similarly, if in this graph, if I will see this point, if I will add 4 here, 4 here, so this will move 4 step up to this, or 5 here up to this, right?
Yeah, right.
Right. So this point will move towards this, but graph is not going to change. This is fx only. I am just adding by a constant. It means that this whole graph will shift from this point. So this whole graph will look like this. Graph will be same, but I am just shifting the point. Just see the x-axis. I am just shifting the prime point by 5. Similarly, if I have k here, if I want to add 4, so I will just go up to 4 step and I will get a k plus 4, right? Right?
Sir, this is adding plus 5 to y, right?
Yes, sir.
Yeah, adding plus 5 in. Okay, it's adding plus 5 in y.
Yeah,
Okay.
that will shift upward.
Okay, just a minute. Okay, I am adding this thing in y. So what does it mean? It means that here itself. So suppose this is your 4. This is your k. Now, if I want to add 5 here, so what it will be? It will be plus plus, and then I will reach something here. So this point will go from here to here. So this point will go from here to up to this, whatever thing is there. Okay, it means that up to 5 is that this point will go to here to here. It means that this graph will go like this. Got the idea? It means that this graph will move in the y-axis. If I will add, it will go up direction. If I will subtract, it will go in the down direction. Got the idea? So let's check this whether this thing is correct or not. So I am adding this. This is means here 0, 9 is there. Here something is there. Something will be there. I don't know exactly right now, but yeah, what it will be here 9 minus 9 0. Now let's check this. This equation is what? This is x plus 9 now. Y is equals to x plus 9 will look like this only. This is the equation of y is equal to x plus 9. So got the idea? Basically what I am saying, if fx is something yours graph, y is equals to fx, then fx plus h, how will it look like? If h is your positive, then fx plus h and fx minus h. How will it look like? Suppose this is your graph. Fx is equals to x square or something x square plus 3. So if I will add something positive value here, so it will move from here to here in that positive up to that positive value, and here this will become fx plus h. Okay, if I will subtract some positive value, so it will go down direction by that value. Got the idea? It means that if I will add in the y, this will move in the y-axis. The graph will move in the y-axis. If I will add some positive thing, then y will go upward direction. If I will subtract something, then it will go downward direction. Simple?
Yes.
Got this? Any doubt here in this translation?
No, sir. Clear.
Clear? Everyone? Now.
No doubt. Yeah.
This is clear. Now let's talk about this. Y is equals to fx plus h. Now here I am adding in the x. Okay. So similarly, if since I am adding in x, so this will move in the x axis, right? Same example. Fx is equals to x plus 4. Same example we will take. Here, since I am adding in the x thing, so what it will be? This is your x plus 4 graph. So if I am adding something here, means that this is your x coordinate. I am adding in this x, means that here it was something. So if h is greater than 0, it means that it moves this by this direction. Sorry, Ayush Datta, you want to say something?
Oh no, sir, I was actually listening.
Okay, so if I will add some positive value, suppose this is minus 3 and I just want to add 2 here, so this will go by this direction, it will become minus 1, right? Right?
Yeah.
It will move in the x-axis.
Yes, sir.
Right? So it means that whenever I will add something, so in this case, x plus 5 x plus 4 was there initially. I am adding x plus 5, then 4, so it will become x plus 9. Similarly, if I will see here, if I will add 5 here, okay, so okay, there was something
that will
I did wrong.
that will move in the reverse direction, like
in the
if we
reverse
add
direction.
positive,
Yeah, exactly.
Yeah, if we add positive,
yeah,
then it will
just a
move
minute, let me see.
negative.
Yeah, just let me see what is the this one here. If something is k here, so basically if I am adding something in this k plus 5, okay, k plus 5 has to be there itself. Okay, why it is going to this okay, let me figure it out what is going on here. Okay, let me see in the x square thing. If I will put x minus 2 whole square, what does it mean? initial point was 1, so I was taking 1 minus 2. The whole thing, 1 minus 2, which is minus 1. So it will become minus 1 whole square. Okay. So if in the x-axis there was 0 point, or 0, if I x1 is 0, if I it will be minus 2, then 2 will become 0. Okay. Cameras, please mute yourself. Okay. Okay, let's. So basically what it will be, let's take fx is equals to x square example. Okay, this thing will not going to like that thing. Okay, so what is the graph of this fx is equals to x square? This is right.
Yeah.
Right. Now if I will add this x plus 1 something, so what it will be? X plus 1 whole square. Right?
Yes, sir.
Yeah. Yeah.
Now here initially the graph is started in the x-axis. If you will see, the graph is started that peak point, or you can say that vertex of this graph is x is 0 0, right? In this case, vertices of this graph is 0 0.
Yeah.
Now here in this case, if I will put 0 here, so basically I need where see if, since I am changing this any change I am doing in the x thing, I know the thing that this graph will either shift by this way or this way, right? This thing I know.
Yeah.
Right? Means that this graph always touch the x-axis, that I know, because I am changing in the input thing. So the thing is where this graph will touch the axis. So if I will put x is equals to minus 1 here, then I will get 0, right?
Yeah.
So basically this graph will upgrade, and then this graph will look like this.
Yeah. At minus 1 0.
Yeah, exactly. So this will become your minus 1 0. So basically what I am trying to do, whenever I am adding something in your domain, I have to somehow manage those things from the graph, right? In the initial thing, I have to manage that particular thing, right? If I am adding in this graph, something is adding in this graph. Suppose I have k module, k unit thing I have. Now, in this initial k thing, I am adding some 2 thing. Okay. I'm adding 2 more unit in this k thing. Or you can say I have k chocolate, or I have k pen. I have k pens, and I am initially after adding I am doing this like after some time I am adding 2 more pens. Okay, but I need only k pens. So how many pens we will get extra? 2, right?
Yeah.
So if I have to distribute this pen into the k student, so I will left this 2 pens because I add this 2 pens extra after some time. So somehow I need to manage this 2 pen. So basically what I will do, I will remove this 2 pen, right?
Yes, sir.
This 2 pen I will remove. So that's what I am saying.
So
I am saying because here I am just adding something extra. I just need to adjust this thing in the graph.
yeah, that
So
is
for
all about
adjusting thing,
management.
what I am saying, I am just going this direction, and I am making my graph like this. Like this. Here I adjust this thing. Why this going this direction is wrong? Basically, if I will go this direction like this, now in this from this equation at x is equals to minus 1, I need what? I need the root, right? I need the whatever roots are there for this quadratic equation. I need that. But here, if I will put in this equation, is as we can see, this is 1. So as you can see, the roots which is we are getting the roots that we are getting at 1, x is equals to 1, right? So this is somehow incorrect, because here I am just adding one more thing. I am not adjusting that addition part, right?
Yes. Yeah.
Right? For adjusting thing, so what is the rule here? Rule here, if fx is there, y is equals to fx is your function, and if you are adding some a which is greater than 0, okay, you are adding a in this x, so your function, if your function was okay, so your function will shift a unit in the left direction if a is positive, okay, and if your a is negative, then it will move a unit in the right direction. Okay, so basically if I will say a is greater than 0, then left direction. If a is less than 0, then it's right direction. Okay,
And this will be applicable only for exponential functions. Exponential because
every function, at any
every
function, this will be applicable. Every function. I am just writing this for each and every function, not specific
when
for
we tried
exponential.
for that linear function,
Whatever function you want to take, you can take.
Okay.
This is applicable for each and every function that is exist.
Okay.
And so what if it is f of x minus a, the reverse will happen, right? For
Yeah,
a
that's what
greater
I am
than
saying
0,
now. See, a greater than 0, a less than 0, what does it mean? It means that I am adding x plus a once, I am subtracting x minus something k, which is k, where a and k both are positive. So here, for the sign of a, I am taking both the possibilities, f of x plus a and x minus a, both the things. So basically, if I am adding something in my input, I have to move that much unit in the left direction. If I am subtracting something, the positive thing I am asking about, positive thing. If I am subtracting something, I have to move in the right direction in that unit. What the idea?
Yes.
Okay. Now this thing is also done.
Sir, I actually had a question that is kind of off topic but related to week 4. Is it okay if I ask it now or later?
Yeah, you can ask after completing this, whatever thing I am. Okay. Now, what about this? If y is equals to minus fx is there. In this case, basically what I am trying to say. Initially, my graph was looking like this. My graph was like this. And I was say just take the minus of this. So basically, if I will apply the minus sign here, this will just this will just reflection, or this will become the reflection of this x-axis. So it will be like this. Okay, you just flip this graph along the x-axis. If minus sign will apply here. So basically what this minus sign will say, what are the positive values was there in the initial thing, that will become the negative value, this one. And what are the negative value was there in the initial thing, that will become the positive value. That's the thing. If I am applying minus in this fx. Okay, so what you need to do, you need to just flip the graph along the x-axis.
like a mirror image.
Not mirror image, you have to just flip the graph. Okay, just hold this thing, and just hold this thing and just
rotate 180 degree.
Yeah, rotate 180 degrees. So you will get here.
Along x-axis.
Or you can say just flip it.
Yeah, just flip.
Just take this and you will got this. Okay. Mirror image, why it is not mirror image? If you will take mirror image, this will go like this. Okay. Okay, you can say mirror image as well. Yeah. But flipping thing is a more appropriate way to say it like this. Like you just flip along the x-axis. That's it. Okay, mirror image is also fine. Fine for everyone. The minus thing.
Yes.
This is that. Okay, what about this input? If y is equals to minus of this. Okay, what will happen basically? So in this case, your graph will flip along the y-axis. Okay. So if initially your graph was like this, so after that, basically, what does it mean? It means that what are the positive value in the input, just take it as negative value, and what are the negative value are there in this set, you just take it as positive value. Suppose you are putting x is equals to -2 here. So in this, because of this minus, it will become minus of -2, which is 2. Okay, so basically you are flipping your graph with respect to y-axis. So this will become, understood? Okay, in the input
Yeah.
set, your positive value will become negative value become positive value. So basically what you are doing, you are just taking this, you are just rotating your graph 180 degree along the y-axis,
Yeah. Yeah.
or flipping the graph along the y-axis.
Lateral inversion.
Huh?
Lateral inversion, sir.
What is it?
The same thing you did, like right is left and lateral
Yeah,
inversion.
exactly. Yeah. Okay, lateral inverse. Yes. Fine. So this thing also done. Okay. Now, last thing which is remaining here, if I will multiply by some constant, what it will be? Basically, this multiplying by some constant, this will just amplify your graph. Amplify, it means that if your graph is look like this, either this will subtract your graph like this, or this will stretch your graph. Like initially, if you will multiply like this, so your graph will be more closer to the y-axis, or there is a possibility that it will be more far from your y-axis. It depends on the constant, what are the constant you are applying. Okay, I don't think so this is more that much useful in the finding of root, but it's still, if you will multiply some k which is greater than 1, then it will very close to the x-axis, very close, it will go to the close of y-axis, and if you will multiply which is less than 1 and greater than 0, then it will be spread like this. Or you can say, if you will take any value from less than -1 and greater than 1. So basically, in this case, you understood now. If you will multiply any constant which is greater than 1 for the equation, this will go more close to the y-axis. If you will multiply any constant which is from 0 to 1, which is in between 0 to 1, it will be the like more far from this. It will be far from this y-axis, from the initial one. Okay. Now, if you will take any value minus k, so basically, firstly, this graph will be flipped because of minus, and then same thing will happen. Okay, this graph will be rotate 180 degree along the x-axis because of this minus. Because of this this minus is going. Okay, where is it? This minus is going in the fx itself, right? Okay, this graph will be flipped. Yeah, this graph will be flip along the x-axis, and then it will be stretch and spread according to the k is greater than 1 and whatever things are there. You got the idea what I am trying to say basically?
Yes.
Okay.
So,
Yes. Please, Bhumika.
if it is 5x and 3x, then the 5x will be more closer to the y-axis now.
Exactly. 5x will be like this, and 3x will be like this. So 5x is more closer than this. Okay.
Yeah, I mean 5fx.
Whatever thing is there here, if you are considering fx is equals to x, then 5x is more closer than x. Yes, 5 of f of x, this is also more closer than this.
Yes.
Suppose you are taking this k1 and k2 both are positive and k1 is greater than k2, then k1 fx is more closer than of y-axis than more closer. The distance between this graph, this 5 times k1 times fx is lesser than this. It means that this graph will be more close of y-axis than the other with the k2 graph. Okay.
Yes.
So got the translation? What are the translation? So you can apply this translation with any graph. No restrictions are there. Okay. Okay. Please tell me. Okay.
Is there a difference between k f of x and f of kx?
K f of x and f of kx. Yes.
Yeah.
Okay, that thing I haven't explained, right? F of kx. Okay, so there is no such changes in f of kx. Basically, what does it mean? If I will put x plus 3 here, this is my function, fx is equals to x plus 3. If I will multiply f of kx, so it will become more closer than of, like, the slope will be changed in this case. In this case, the slope will be changed. Then what will be the basic thing? Like,
no, it applies
what
to
will be the changes?
isn't it? Kx plus k3 or 3k in this case.
In this case, only kx was there now, because you are replacing this x by kx. No changes will be on.
No, whatever
just
was
replaced.
x earlier. Oh, okay. Only k.
Okay, because what this function is doing, this function is taking some input value and just adding 3 on that input value. So here input value is kx. So you just add 3 in this kx. That's the thing.
Okay. Oh, only for k times f of x, it will be kx plus 3k. Is that right?
It's just changing the slope.
Here we are
It's changing the slope according to that.
Okay.
Well, this is not so necessary, this thing.
Okay. All right.
Okay. Because the roots will be the same in this case. Not going to change. So we are going this thing because we need roots and all things, right? The roots will going to same for that case. Or whether it will going to change.
Okay.
Yeah, it will going to change. Okay. Let me think what will be the changes happen in this graph. Okay, basically if I will take k is equals to 2 here, what it will be? F of 2x, which will become 2x plus 3. So initially graph was like x plus 3 is there, right? Okay, so graph was like this. Initially this was f of x graph. Now if I will put this 2x plus 3, so 3 will be there, same. Now here x is equals to minus 3 by 2. Minus 3 by 2 is around minus 3 by 2 somewhere here. So this will become your graph. Okay. So the slope is changing basically. Initially the slope was 1. Now here slope was 2. Will be 2. So initially slope is changing. This whole thing, the x, like the y-intercept is same, and this graph is going towards closer and closer of this thing. Okay. Now if you will multiply 1 by 4, so suppose 1 by 4, then this graph is going far from the x-axis.
Okay.
For this y-axis itself.
Right.
Okay.
Okay.
Similarly, if you will see x square, fx is equals to x square case. In this case, what will happen? So, or you can say, since we were talking about this e raised to the power x plus 3 something. So basically here x plus 3 is there. What is the initial graph? we are adding something, so we will go towards this. So basically, the function graph will be the same. Okay, here we will get the one value at x is equals to -3. Here this will become, this is your one. So this is your graph. Okay, this is e raised to the power 3. This is your graph initially. Now if I will multiply 4 something in this x, what it will be?
I mean, it will get closer to the y-axis. I mean, y-axis, yeah.
Basically, if I will put, we will see by the, what is the roots of this? X is equals to -3/4. So basically here I was getting at -3, I was getting one value. So I will get at -3/4. -3/4 is somewhere here. So this graph will be look like, so this graph will look like, so here I will get one value. So this graph will be look like this. Okay, look like, not like this here.
The y-intercept will be same.
Yeah. Right. The graph will be look like this. The y-intercept will be the same thing.
Okay. Yeah.
Okay.
Yeah.
This graph will go rapidly like this.
Okay.
Okay. This is the thing.
That means as the power increases, it will become more and more closer to the y-axis.
Not exactly, we can say, not like that. We can say like it depends on the constant what we are multiplying. We cannot say directly from here. Like it depends on the graph itself. But that what we can see, the slope will be changed. But y-intercept will be the same. That we can say. The y-intercept, what are the y-intercept we will get, that y-intercept will be the same always. Okay, that we can say. But we cannot say the nature of the graph. Like
But if we multiply
most probably the
positive
slope
values,
will be different. Yes.
if we will multiply the positive values, then it will be like closer to the y-axis now.
Not exactly. That's what I am saying. Like if you will multiply by this by 1/4, so it will go like this. Understood what I am trying to say? If you will multiply 1 by 1/4 here, so this graph will go like this. Now, how will you say this is closer to the y-axis? It is going towards this, no? Basically, it is closer to the x-axis that we can say. What I am trying to say basically. Basically, that what thing that you have to remember, if you are multiplying some constant by the of the equation, so the thing is, just see the one thing that you know, slope can be changed. Slope will be changed. That will according to the constant. And the another thing is that y-intercept will be the same. Most probably x-intercept will change, but y-intercept will be the same.
It will be steeper.
Okay.
Yeah.
Sorry?
It will become more and more steeper as we increase the value.
Increase the value. Yeah, that you can say. The slope will be changed. And also, what will be the change of x-intercept? See, y-intercept will be same.
Okay.
And what about the x-intercept?
But we don't have
you
x.
Are multiply. Yeah, if your x is equals to alpha was your initial root or initial zero of this kind of equation, then if you will multiply by k, then x is equals to alpha by k will become your root.
Okay.
Okay. 0. See, here there is no such root, but I am just saying if you are multiplying and the roots are adjust. If you are talking about x-intercept, then if x is equals to alpha is your x-intercept, then you are multiplying with k, then x is equals to alpha by k will become your x-intercept in that for the new function that you got.
X tends to alpha by k.
Yeah, but for this function, this
there is
rule
no
won't
such
be
root. In this
applicable,
case,
right?
there is no such x-intercept. So we will
Yeah.
not going to talk about the x-intercept.
Okay.
I'm talking about in general. Okay, fine.
Yeah, understood.
Okay.
But I think we have to go through this entire thing again and again.
Yeah, you have to see. You have to see this thing. You have to make like you have to practice on this thing. That's it.
You will be
You have
sending
to
the
make
PDF,
some graph
right?
and all. Yeah, I'm going to send this PDF. Yeah, even still, I just send it now. I know.
Yeah, thank you.
Okay, others guys can leave the session. I have sent it. Okay. Good night, others. Okay, just see. I have sent the PDF. Just look at. Just download it and let me know if you have completed.
Yeah, downloaded. Thank you.
Shall I add the session?
Yeah,
Yeah.
I actually had the doubt from last session, by the way. Like
Yes. What was
on the
the
last. Yeah, so basically in the last session, we raised a concern about one of the questions, polynomial questions from quiz 1. And professor said that he's going to resolve it and get back to us. So I was just wondering if it has been resolved or not yet.
which question?
The one where there was multiplicity of A and B are the same, like like the points -1 and 1 are the same. That one.
That was resolved. No, that was a result. I was saying like that. Yeah. See, the thing is the multiplicity from there we can only say about the multiplicity can be same. We are not say maybe same, that we can say. We cannot say it must be same. Okay, by with the nature, by the graph of nature of the graph, because it's just passing through the axis. Okay.
Yeah,
And
yeah,
also we
got
will not go, we cannot say like there is no such S set, because the past term that we have, see that thing, that S curve, that we can say only when we have x raised to the power n things. And if n is odd and n is greater than 3, then we will say, yeah, it will make a S curve. Right? If something is there apart from that, like x raised to the power n, then 5x raised to the power n minus 1, that thing will happen. So in that case, that whatever the S curve is there, that may be destroyed by that past term that we are getting after that x raised to the power n minus 1. That will affect the S curve. Okay. So from that question, we can only say, yeah, the multiplicity can be same, but it need not be same sometimes. It depends on the functions.
Okay,
Okay.
but I actually saw like
So
so many functions. I tried like so many functions, but I never came up with one that like the S is getting destroyed. I don't know why it's happening, but is it possible that you can give me an example of any curve where it's getting distorted?
okay, any curve that you are saying, like okay.
Yeah, something like the one in the
Okay, as you can see, you can go get this x cube. Okay, let me show in GeoGebra. Okay,
yeah
x cube itself we can say.
X cube.
Yeah, x cube we will get this S curve, right?
One moment, I'll just quickly open the Desmos.
I am showing you. I am showing you.
Oh, okay. Yes.
Okay, if you will see x cube here. Right, this is not happening.
I think you have to put y equals to x cube.
Okay, this is your S curve, S shape curve that you are saying, right?
Yeah.
Now, as I will include some extra term like x cube suppose plus 2x. See, after introducing 2x here, the s here, like the s curve that you are saying, it is distorted.
No, sir, not like that. What I'm trying to say is that it should be in the same type of as that graph, right? Where all the it should be in factorized form, right? Because it cannot be other than that, right? It won't gonna have the exact number of roots as that graph.
So
I saw
what
like
was that question?
that question. Wait, I have
See,
to.
there was this kind of graph, right?
So I'm trying to say that there is I cannot find any graph with those similar roots, like those similar number of roots and similar number of maximum and minima, general local minima and maximas, where there is not a s. But I
Yes.
can find different s's, no s when you add some other terms, but particularly that kind of graph, it's not possible.
Okay, so where is the thing? This is that question was like this basically. This question was like this. So at 1 and -1, the question was the multiplicity of these two must be same.
Yeah.
That was the question. Okay, so they may or may not be same. So someone was like, sir, if x raised to the power like x minus alpha raised to the power cube is there in the factorized form. Okay, so sir here and x minus beta cube is there. So sir, here multiplicity is same, and in the here you can see this portion and this portion is looking like the behavior of in this both portion is same, exactly same. They will say yeah, must be same, but that is not incorrect. That is incorrect. Why? They will say yeah, the multiplicity of this point is 1 and this point is 1. That they were saying because of this crossing thing. So my argument of this point is that with this is they were saying, sir, if the multiplicity is cube, like this cube multiplicity is more than 3, then you have to get here s curve and here also.
No, not just more
Right?
than 3. If it is greater than 1, you're
3
gonna
itself.
get this graph.
Yeah, not greater than 1. If you have even multiplicity, then it will
Odd
it will
and
not
greater than
going
1.
to
Yeah, so it
s.
should be at least 3.
Yeah, or yeah, that's what I'm saying. So basically, it won't be S curve. You cannot get S curve in that case. Basically, in this example, also you can say you have what x cube plus 2x, right? This is also the degree of this polynomial is 3, right? So here, what is your root? What will be your root? Okay, so you have to get S curve here, right? But you cannot get S curve here.
Yeah, but the thing is, it will never be of the form that is similar to that graph. It will never have that many roots.
That kind of thing that you are asking. No, whatever it is, whatever thing it is, if I will include more of see, this graph is another graph. Okay, if I will include some more portion, that graph will be look like this. I cannot interpret that what is this graph exactly. I
But
cannot say
the
like
graph was
that. It
given in the
depends on the
equation, right? But the graph was given in the question, right?
The graph was given in the question, but we are not aware about the equation of the question. That graph can look like, say, corresponding to that graph, there may be infinitely many equations.
Yeah, but the equation should be of the form, where all the roots, all the real roots. So it should be of the form x minus a times x minus b, x minus c, where a, b, and c are all the real roots, times a constant a that is in front. That should be of the form
But
like a.
there may be possibility that this x minus a, x minus b that you are saying, there may be possibility that here there may be some multiplicity,
Absolutely.
5, that kind of thing.
Absolutely, yes. And
Okay.
even if we take those
So in
multiplicities, right, and still I cannot find any any graph that is other than S curve.
Exactly. So the question was the multiplicity must be same. That must what will not be happen because there is a possibility that here you will get 3 multiplicity, here you will get 5 multiplicity.
Yeah. Now what I'm trying to say is that if we take the real roots that are given in the graph and we form an equation.
Suppose real roots are 1, -1, 0, and 1. Then what?
Yeah. So if this is true, then if the equation should look like a times x plus 1 times x minus 1, right? Huh. Times x plus something, like, whatever that is, which is like not like, won't gonna contribute to real roots. So even if I do this, I was unable to find like any like, non-S curve type. That's
So
what I'm
what you
saying.
are saying basically, if the roots of the polynomial is this, then your equation, the polynomial will be of the form this. That's what
No,
you
no,
are
no. What
saying.
there can be x plus something also where we are not getting any root. That is also possible, right?
Yes.
But even if we
Yes.
take that into consideration, I was still unable to find any like, possibility where because whatever we take x plus that value, right, it won't gonna contribute to the curvature of the, s at that point. That's what I'm saying.
Yes.
If it is
So
lower,
basically
then
what you are
it will gonna lower the like, intensity of the s. If it is high, it will like increase the intensity of the s. That's what I'm saying.
yes.
But it will never gonna make it disappear. That's what I'm trying to say.
Yeah. Okay. So the thing is, if you have these three roots only, so there are so many possibilities. Like if you will add, suppose you are saying, yeah, this
Yeah.
term is also there because here I am not able to find the root. So this thing are also there. Yeah, I am agree with that. But the
Yeah.
thing is, yeah, this will affect your curvature of the graph,
Yes.
whatever
Yeah.
it is. This will affect that thing. But the thing is, if you have this root, you
Hmm.
cannot say like that the term form which are coming from this root, which will look like this only. Here there is a possibility that here
Yeah,
you will
yeah,
get
yeah,
3.
absolutely.
Here
There
that
can
thing
be
will
5.
happen.
Yeah,
Yeah,
yeah, absolutely. But
that
the
thing
thing is,
also.
but the thing is, if you're gonna have like, odd multiplicity and that is greater than 1 in -1 and +1 root, there will always be an S curve. That's what I'm trying to say. But there
No,
was no S curve in the equation, right?
no. If the equation of the form x raised to the power n, and in this case only this, there is no term behind this.
Hmm.
After this x raised to power n, there is no curve, no term.
Hmm.
Then you can say there may be possibility of S curve. Okay, but if something are there after this, so this will affect the x curve, as I have shown in this example. Initially I was this x cube. I have that example of x cube. I have seen this. We got this this S curve. Now I add this extra term here, 2x. Okay, so now in this case, what I got this, the thing that here at the whatever thing is there, what to say, yeah, the S curve that we have got, this is distorted right now,
Yeah, yeah, yeah. Okay,
as you
sir,
can
can
see.
you do one thing? Can you include like in the second
It is
equation, can you include like two roots? Let's say like, put that in the bracket and put x plus 1 and x minus 1 and see what happens to the graph once in the second equation. Hello.
Am I audible?
Yes, sir, you're audible now.
Yeah, actually my internet was gone. So
Oh,
basically what I am saying, so if I will take this
yeah, but your screen is
and
not audible, sir. The screen is not visible.
okay, just a minute.
Excuse me, sir.
Okay, so basically you know the yes,
Sorry to interrupt you. Actually,
yes.
I'm not able to open that PDF that you have shared. Like I have downloaded that
That
Microsoft
same
Word.
way,
Sorry, sir.
same way, Bhumika, like that you have done in the last.
Sir, I have downloaded OneNote also, but I'm not able to open that. I don't know why.
Yes. Okay.
So how,
Uh,
I got
okay.
someone shared the
Someone please
PDF.
may
No, someone shared the PDF, but why I'm not able to open that PDF, sir? That you share.
Okay, so the problem with the PDF is you have to change the extension of the PDF. Then the extension of the PDF has somehow become .pdf dot something. So you have to remove that something and then make it just PDF.
Okay.
I'll share the PDF with you.
No, I got it. I got it.
Got it, right? Okay, perfect.
Thank you.
Mhm. Yes, sir. Yeah. So basically, what I was trying to say is that even if you take an equation with let's say x square plus x cube plus 2x, the one that you showed, and then x plus 1 cube and x minus 1 and x plus 2, like the one in the equation, in the graph. Still, in that case, also you're gonna get a S curve. Like even if you
okay. Yes, you are correct. But the thing was if you have x minus 3 cube and something, so after the greater than thing, after greater than 0, like 3, if something is in the power alpha which is greater than 3, even the S curve will be the small and small, but there will be some S curve.
Yeah, absolutely.
Yes,
And that should be
that's right.
visible. That will
Yes,
be visible
so
even
most
over
probably you will get extra marks for that. I will let them know. So is there did you talk something about that to anyone?
I actually just talked with the other TA who was taking the previous session, but he said he will talk with the professor and get back to us, but he did not let anything know to me.
Okay, so I will inform them in the Tuesday's meeting. So most probably you will get some extra mark. And basically, if it is incorrect for everyone, so it doesn't affect that
Yeah.
much. Oh, you don't have that it's not like that. But you have to just pass. For passing, you have to go for more than 40 marks. You have to attend, right?
Hmm.
It
I
is not
actually got
like
only that question wrong.
the percentile thing is not there.
Yeah, I actually
Sorry.
just got only that question wrong. So I was just aiming for that 100, but I got that question wrong. It's
Can
kind
you
of
please send me that question?
yes,
Can you
I'll
please
send.
send me that
Is
question?
it okay if I can get your email address?
Yeah. Just send me that question. I will let.
Okay, sir.
Okay. Okay.
Yeah.
Okay, I'll write. Okay.
At the rate. Okay. Try to find the question. Maths.
Okay, just email me. I will inform them.
Yes, sir. Yes, sir. Just let me know the email address.
I just send it to you.
Okay, sir. Got it. Perfect. I'll send you
Or
the.
also I will look at like I will check whether it is correct or not. I also have to see what is the thing that are going there.
Yes, sir. Yes,
Okay.
absolutely.
I need to check.
Okay, sir. Perfect. Thank you. I'll send you the email tonight.
Okay.
Basically the main argument was that you'll just notice even if it is very small jolt, you'll just notice that very small jolt. That's the thing.
Yes.
Okay, sir.
Bye bye. Good night.
Good night, everyone.